1. So let's do 3 examples for simplified fractional exponents type 2. Okay, so it looks a little bit different, but we're going to simplify the following expressions simplest form using only positive exponents. Let's go like that, just so there's more space. Okay, so we're going to essentially distribute this negative fractional exponent to everything inside the parentheses. So this is going to be 81 to the power of negative 5 over 4 times x to the power of 4 to the power of negative 5 over 4 times y to the power of 32 to the power of negative 5 over 4. Okay, and we are going to simplify each of these pieces. So that's going to be fun. It's like 3 problems in one. Okay, so we have 81 to the power of negative 5 over 4. Let's leave that one for now. And then let's deal with the x's and the y's just because I think those are simpler. So we're going to multiply these two exponents, x to the power of 4 times negative 5 over 4. So if I'm just going to multiply these exponents, this is 4 over 1 times negative 5 over 4. The 4's get to cancel out, and we are left with x to the power of negative 5. And then for the y piece, this is 32 over 1. So when we are multiplying 32 over 1 times negative 5 over 4, our 32 and 4 can cross cancel. I just like canceling before when there's like a big number. So 32 divided by 4 would be 8. So cancel. This 4 becomes a 1, the 32 becomes an 8. So then we can multiply straight across. It becomes 8 times negative 5 is negative 40 over 1 times 1 is 1. So it's negative 40 over 1. But we can just write that as negative 40 because negative 40 divided by 1 is negative 40. So since I did a little bit of a shortcut there almost, I didn't write out that we're multiplying it, but I just multiplied it straight across. Do you guys have any questions? I'm going to pause the video to see if you have any questions. All right, so we have 81 to the power of negative 5 over 4 times x to the power of negative 5 times y to the power of negative 40. I'm going to rewrite this on the right because I think I have more space there. So since these are all negatives, I'm going to move them to the bottom of the fraction. So right now everything's over 1. But since we have negative exponents and we don't like that, we're going to move it from the top of the fraction to the bottom of the fraction. I'm just going to keep the 81 to the power of negative 5 over 4 there first. But the x and the y, I'm going to move it to the bottom now. Okay. So all we did here was take the negative exponent pieces on the top, move them to the bottom of the fraction, and then we changed the exponents from negative to a positive. Now, let's deal with that 81 to the power of negative 5 over 4. Okay, so 81 to the power of negative 5 over 4 is the 4th root of, actually, let's move that one to the bottom as well. My bad. I think it'd be easier if we move it to the bottom so it's no longer a negative. So let's move that one to the bottom. Where do I have space to write this? I'm going to just make my fraction a little bit higher. Okay, so then we move that 81 to the power of positive 5 over 4. And then x to the power of 5, y to the power of 40. Okay, now we're going to put it in radical form. So put it in radical over here, radical 81. It's the 5th power because that's the numerator over here. Well, I don't know why that looked like that. There you go, 5th power. And then this 4 on the bottom is the 4th root. So the 4th root of 81 to the power of 5. Pausing here. Okay, so then I forgot to write the x and the y piece. Sorry, I got distracted because waiting room. So then I paused the video and I got distracted. Okay, so yeah, x to the power of 5, y to the power of 40. For this piece, it might actually be easier for us to take the 4th root of 81 first. So over here, let me just rewrite the other parts. So I want us to take the fourth root of 81 first, because that's actually going to be a nice number, and then we're going to raise it to the power of 5. So you can actually move that power of 5 to the outside of the exponent to help us simplify sometimes. So we want to find the fourth root of 81. And so if you were to test out like 2 to the power of 4, 3 to the power of 4, stuff like that, you would find that 3 to the power of 4 is 81. So that in turn means that the fourth root of 81 must be 3, because 3 to the power of 4 is 81. So then, if I'm going to continue this piece, let me just rewrite this piece up on the top so that I can have more space. We need the fourth root of 81 to the power of 5, x to the power of 5, y to the power of 40. Okay, so we just said the fourth root of 81 is 3, so I'm going to rewrite that piece. 3 to the power of 5, x to the power of 5, y to the power of 40. And so when we're finally writing this out, we just need to figure out what 3 to the power of 5 is. So that would be, I think, 243? Yeah, 243 x to the power of 5, y to the power of 40. And this would be our final answer. I'm going to pause the video here and see if you guys have any questions again. I have to remember this. 1 over 243 x to the power of 5, y to the power of 40. 1 over 243 x to the power, x to the power of 5, y to the power of 40. Okay. Let's do another problem. We have 81 x to the power of negative 20, y to the power of 28 to the power of 1 over 4. Okay, so we're going to take this, let me zoom in first. We're going to take this negative exponent and we're going to distribute it to everything inside the parentheses. Only the stuff inside the parentheses, but everything is inside the parentheses. So distribute. This is going to give us 81 to the power of negative 1/4 times x to the power of negative 20 to the power of negative 1/4. I don't know why I wrote my fraction that way, but I want it to be consistent. So let me write it like this. Times y to the power of 28 to the power of negative 1/4. What a mouthful. That was a lot to say. Okay. Now let's do the x's and the y pieces first, just because, I don't know, I think it's easier if we do that. So we have 81 to the power of negative 1/4. And then with these x pieces, we're going to multiply them. So negative 20 is negative 20 over 1. So negative 20 times negative 1 over 4. Let's cancel out the 20 and the 4 because those are simplifiable. 20 divided by 4 can make us have 5 and a 1. So now it becomes negative 5 over 1 and negative 1 over 1 that we're multiplying. So then let's multiply straight across. Negative 5 times negative 1 gives us positive 5. 1 times 1 on the bottom gives us 1. So this is x to the power of 5 over 1. However, you don't have to write that it's over 1. You can just write x to the power of 5. I guess I can erase that part then. Since it's 5 over 1, we don't have to write over 1. So you can just write x to the power of 5. That 5 is floating very high, but it's okay. Then we have the y's. So we're going to multiply 28 times negative 1/4. So this is 28 over 1 times negative 1 over 4. We can cross cancel the 28 and the 4. That makes us have a 7 and a 1. So 28 divided by 4 is 7. So we have 7 replacing the 28 and 1 replacing the 4. Now when we multiply straight across, we have 7 times negative 1. So that's negative 7 divided by 1 times 1. That is 1. So we have y to the power of negative 7 over 1, which of course you don't have to write that it's over 1. We can just write y to the power of negative 7. Now that's floating way too high. So let me rewrite that. There you go. Y to the power of negative 7. I'm going to pause here and see if there are any questions up until this point. All right, so now let's continue by changing everything that has a negative exponent to be on the opposite side of the fraction, and then we're going to make them have positive exponents because that's what we like. Do I have space to the right? I do have space to the right. Okay, so then we're going to move the 81 piece and the y piece to the bottom of the fraction because they have negative exponents. The 5, not the 5. The x has a power of positive 5, so it can stay where it is. It's already happy there. But let's move 81. Instead of negative 1/4, it's now positive 1/4. And y has the power of positive 7 now instead of negative 7. So we just move those two pieces from the top to the bottom. Now, the only thing we have to deal with is the 81 to the power of 1/4. Let's rewrite that as a radical. So I put the radical here. The 81 goes inside. It's to the power of, I'm going to zoom in now, 1. So 81 to the power of 1. Luckily, that's just 81. And it's over 4, so that's the 4th root. And of course, the y to the power of 7 is here. So we have x to the power of 5 on top over the 4th root of 81 to the power of 1. Let me see, I'm going to squeeze it in onto the right again. So x to the power of 5 over, we actually can simplify the 4th root of 84 because, what was it? 3 to the power of 4 is 81. So therefore, the 4th root of 81 is 3. So I'm going to replace this with a 3. So this is our final answer. X to the power of 5 over 3y to the power of 7. And then I'm going to pause here and see if you guys have any questions. Okay, so x to the power of 5 over 3y to the power of 7. I think I can remember that. X to the power of 5, 3y 7. X to the power of 5 over 3y to the power of 7. Okay, let's do, oh sorry, it was lagging. Okay, let's do another one, and then we'll go to the last section. Okay, 27, x to the power of 18, y to the power of negative 24, all to the power of negative 5/3. We are going to distribute, distribute, and distribute. Maybe I could write up here to give me more space. Okay, 27 to the power of negative 5/3 times x to the power of 18 to the power of negative 5/3 times y to the power of negative 24 to the power of negative 5/3. Okay. So then, like we were doing the other times, we're just going to multiply out these exponents. So let's leave the 27 to the power of negative 5/3 for now. Okay, x. It has 18 over 1 times negative 5 over 3. So then we can actually cancel out with the 18 and the 3. Cancel, cancel. That gives us a 6 and a 1. So then x to the power of 6 over 1 times negative 5 over 1. So 6 times negative 5 gives us negative 30 over 1 times 1 is 1. So x is to the power of negative 30 over 1. But of course, we don't have to write that it's over 1. I'm just going to write it as x to the power of negative 30. So when we multiplied 18 over 1 times negative 5 over 3, we got negative 30. Okay, we're going to do the same things for the y. So y is negative 24 over 1 times negative 5 over 3. So we can cancel with the 24 and the 3. Cancel, cancel. That would give us, instead of the 24, it reduces to an 8. Wow, that was a really, really bad 8. 8. Okay, and then instead of the 3, it becomes a 1. So then we have -8 times -5, which gives us +40, and then 1 times 1 on the bottom, which is 1. So we have +40 over 1, which of course you don't have to write that it's over 1, it's just +40. Are there any questions up till here? I'll pause the video. So then I'm going to continue writing. Where do I have space? I'm going to write on the bottom here. Okay, so we have all of this is technically over 1. So anything that has a negative exponent, those two, the 27 and the x, I'm going to move those to the bottom. The y has a positive, so it can stay on the top. So y to the power 40 stays on the top. And then on the bottom, it's 27 to the power of 5 over 3, x to the power of 30. So those negative exponents become a positive exponent, but they're just now on the bottom of the fraction. And then all we have to do is deal with the 27 to the power of 5/3. So we have y to the power of 40 over, now I'm going to put it in a radical. So we have 27 to the power of 5. And what root are we taking of it? Y is not selecting. Okay, there we go. We're taking the third root of it. So the third root of 27 to the power of 5. And of course, the x to the power of 30 is still there. Okay, and then let's rewrite this. Y to the power of 40 over, for the cubic root of 27 to the power of 5, I want us to first focus on the cubic root of 27, and then we're going to raise it to the power of 5. So I'm taking that exponent of 5, moving from inside the radical to the outside, because they are equivalent. So we're going to focus in on the cubic root of 27. So let's see, what can we do with the cubic root of 27? So if you try out 2 cubed, this is 8. That's not the cubic root of 27 then. But if you try 3 cubed, that's going to be 3 times 3 times 3. That is 27. So therefore, the cubic root of 27 is 3. So then over here, back over here, I just don't know how to point, but back over here, where it says the cubic root of 27, we're going to replace that with the number 3. So I'm going to write it here. Actually, I'll write it here. Y to the power of 40 stays on top. But yeah, where we have the cubic root of 27, we know that the cubic root of 27 is 3. So I replace it with 3 to the power of 5. And then x stays to the power of 30. So then finally, to simplify the, all the way, we're just going to figure out what 3 to the power of 5 is. So on your calculator, because I don't know off the top of my head, 243. Didn't we do this 3 to the power of 5 last time as well? So we have 243 over here. So this would be your final answer. Now before I enter it in, I'll give you guys a chance to copy or ask questions. So I'm going to pause the recording. Alright, so let's enter this in. Y to the power of 40 over 243, x to the power of 30. Hopefully I can remember that. Y to the power of 40 over 243, x to the power of 30. Okay, so that was 3 examples of this one. So let's stop this recording and go to the last section.